I recently acquired a used Keystep Pro. It's a MIDI CV controller that has a lot of features. The only problem is that its many outputs are on the back, and that isn't completely compatible with my synth shelf, so I decided to build a patch bay for it. I went into Eagle and designed a simple breakout. There are 3 solder points for an audio cable connecting to a mono Thunkercon style jack output. After sharing a screenshot with a friend, I realized I should add an LED. It will light up depending on the CV signal. And then on the back is a silkscreen square for labeling the signal. I'm going to use 3mm pink LEDs that I've been saving for an occasion such as this, along with 220 ohm 0805 surface mount resistors. I sourced the Thunkercon jacks from Winterbloom so that I could 1. Support Winterbloom, and 2. Get some cat stickers. The idea is that I will create these cables to leave plugged into the Keystep and run the cables up to the breakouts. This will involve a lot of soldering. A while back, I built a custom rack that I designed with Noe. I still love it, and I wanted to make this patch bay work with it. Since the rack was in Fusion, I started by bringing in 23 copies of the breakout PCB and positioning them. I liked the idea of having them above the rack. Then I designed a panel to mount the jacks to. I included M3 mounting holes on the breakouts and holes for them on the panel. I decided to use the existing screws on the rack to attach the panel. There are 2 brackets that attach to the top screw. There's also holding a rail, and then there are 2 popsicle stick kind of things that attach to a lower screw, and that will hopefully provide some extra stability. I 3D printed the brackets and popsicle sticks. I considered cutting the panel myself, but I decided to send it out to be laser cut to make sure it would come out precisely. When I use acrylic for enclosures, I use a scroll saw and a hand drill, so it's a totally manual process. In general, it comes out pretty good, but for larger holes, like the ones needed for the jacks, it can be a little tricky and it can tear out. It was all going according to plan. The PCBs were mounting perfectly to the acrylic. One by one, I was fastening them, inching closer and closer to a finished panel when I suddenly did not have enough assembled PCBs. Now I thought it was strange when I soldered the cables that I had 3 left over when I had ordered 24 cables for 23 jacks. But I accepted the mystery and moved on. I counted the jacks and came to a total of 21. 21 is divisible by 3. This is an important fact because OshPark only allows you to order PCBs in quantities that are divisible by 3. I rushed to my computer to confirm my sinking realization that yes, I had not ordered the correct quantity of PCBs. I had ordered 21, but should have ordered 24. About to plunge into despair while mapping out in my head the consequences of my miscounting, Noe suggested that we mill 2 instead. I went to redesign the board to be single-sided to make the milling process easier, and I also widened the traces. I don't really understand CNC, so I let Noe take the reins on this part of the project. Let's just watch some pretty macro shots. With the 2 missing PCBs milled and assembled, this patch panel was finally complete. I attached the panel to the rack and labeled the cables. Then I brought the rack back to the shelf and started making connections with the Keystep. This may sound strange, but I had actually put a lot of thought into this step. Being a former AV tech, I have a lot of horror stories about badly routed media cabinets and cable tracing follies, so I didn't want my personal setup to meet a similar fate. And then there was nothing left to do but try it out. And this is why I added the LEDs. Not only do they look pretty, but they're functional, let me know when I'm controlling the right signal. I built the patch bay back in November 2023, so it's been in use about 6 months. And I couldn't be happier with it. It's let me have full control over my synth setup in a way I've been searching for, and it's also very organized. At the time, I felt a little disappointed about some of the mistakes I had made, mainly with counting, while working on this, but returning to edit the footage, I'm reminded what a big project this was to take on. So all things considered, it went really well. I'll have the PCB files up for the breakouts. They're essentially a passive signal carrier with an LED, so they might be useful for someone. And with that, thanks for watching. And until next time, this has been Blitz City DIY.